Hello, this is Susan Poss. This is a question that one of my students sent to me on working with scientific notation, using it in conjunction with multiplication and division processes. So here's the first one I wanted to work. You'll notice that none of these numbers is written in scientific notation. So the first thing I'm going to do is to write them in scientific notation, which of course you'll remember means you want to go into each of these and position the decimal point so that you have a single non-zero digit appearing before the decimal point. All right, so when I convert to scientific notation, this is going to be 4.5 times 10 to the negative 2. Because when I take this back 2 spaces to the left, it will take me back to the original value, 0.045. All right, moving on to the second one. To put it into scientific notation, this is going to be 3.7 multiplied by 10 to the negative third. And again, the reason for that is because you need to move this back 1, 2, 3 places to get back to that original value that we started with, the 0.0037. All right, moving down to the bottom, I see a 3.7 times 10 to the negative 1. And I see a 1.5 times 10 to the negative 2. Okay, so I'm noticing now, as I look at this, I see notice all of these operations in here are times operations. So each of these individual pieces is a factor, and a factor can be canceled out, divided out. So I'm noticing this 3.7 here, matching the 3.7 down there on the bottom. So I'm going to go ahead and get that out of there, which makes my work a lot easier, I think. So let's see what I have left on the top. I have 4.5, and now I'm going to, let's change color again. I'm going to look at this base 10 to the negative 2 times the same base 10 to the negative 3, which is going to bring me to same base 10 to the negative 5. And on the bottom, what I have left is the 1.5. And again, then I'm looking at the base 10 to the negative 1 and that same base 10 to the negative 2, which is going to bring me to base 10 to the negative 3 as I add those exponents. All right, so at this point, I would pick up my calculator and I would type in 4.5 divided by 1.5, which of course are these whole units, they're not whole units, these numbers out in front of the base 10, and that, of course, is going to give me 3. And then remember, when you divide like bases, you start with the exponent in the numerator and you subtract the exponent in the denominator. So it looks like I'm going to end up here with a negative 5 plus positive 3, or 3 times 10 to the negative 2. So that's in scientific notation. And if you wanted to convert it to standard decimal notation, you would pick that decimal point up and you would move it back 2 places to the left. All right, so that was the first one. I hope that's helpful. Let me move on to the second one. And I forgot to write it down, so give me just a minute here while I write this down. So that piece of this problem is already in scientific notation. Notice the 960 is not in scientific notation, so that's the first thing you'll see me doing. All right, so I've almost got it copied down here. Again, the rest of this is in already in scientific notation form. All right, so let's begin by copying. And then let's convert this to 9.6 times 10 to the second. Again, remember what you're doing there. You're placing the decimal point so that it falls right after a single non-zero digit. And of course, you'd have to move this 2 places to the right to get back to the original. All right, so then let me just copy again this part on the bottom. And then I'll start to do the work. All right, so let me grab my calculator. And the first thing I'm going to do is look at this whoops, that's not what I wanted. I'm going to look at this 2.8 and multiply it by the 9.6. All right, so 2.8 times 9.6. Sorry. 2.8 times 9.6 gives me 24.96. And then I'm going to go ahead and work on this base 10. So base 10 to the negative 2 multiplied by base 10 to the positive 2 gives me base 10 to the 0 power, which remember, 10 to the 0 power is equivalent to 1. Now, that top piece is not in scientific notation because it's got these 2 places here in front of the decimal, but I'm not going to worry with that just yet. I'm going to wait until I finish the work and see how it turns out, see if I need to make an adjustment. So now I'm multiplying 1.6 times 5.6 to get 8.96. And then I'm looking at the bases, base 10 to the 7th and base 10 to the 3rd is base 10 to the 10th. All right, so now I'm going to go in here and take these two numbers, the 24.96, and divide it by the 8.96, and I'm going to get, hold on, I must have something wrong. That's not what I got before. Let me see if I've copied everything down right. 8.96, hold on, can't find it. 2.8 times 9.6 is 26. Oh, this is wrong right here. Sorry. Let me double check it. 2.8 times 9.6 should have been 26.88. So I had a mistake there in my typing. I don't know what I did. All right, so let me try this division again because I know I'm supposed to come out with a 3. 26.88 divided by 8.96, yes, is 3. And then base 10 here, when I divide bases, you start with the exponent in the numerator and you subtract away the exponent in the denominator. So we end up with 3 times 10 to the negative 10th. That is in scientific notation. And if we were asked to take it to standard form, I have to think about how many zeros that would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 3 itself would be the 10th. Let me take a look at that. So if I move that 10 spaces back to the left, is that right? I'm having trouble making sure I've done this correctly. Yes, I think that's correct. That takes me back to where I want to be. All right, so I'm hoping that this is correct, and I'm hoping that this will help with working with scientific notation, multiplication, and division.